So the whole idea with Pearson's is we want to see if there is a correlation between Stan's score and Minson's score. Effectively, if we were to monitor the scores on a graph, is there going to be a positive correlation like this? Or alternatively, is there going to be a negative correlation? Next, I want you to have a think about how this correlation is different from the last correlation I drew. Excellent. Hopefully you notice that this is a weak correlation. So not only is it different because it is showing as one variable increases, the other one decreases. So as the x increases, the y decreases, but there is not a real strong pattern between the two. There's some outliers, there's not really a straight line which would join them all together. And this is really essential for Pearson's. And the reason why is for Pearson's, we have three key numbers we want to look at. We have -1, 0, and 1. -1 represents a really strong negative correlation. 0 represents no correlation. And the 1 represents a strong positive correlation. Anything in between 0 and 1 is a positive correlation. If it's between -1 and 0, it's going to have a negative correlation this time. However, the closer it becomes to 0, the weaker the correlation becomes. So let's see how this works in practice. You can normally see by just glancing at the data what kind of pattern you're going to have. And because this is to do with judges scoring a competition, you're going to expect that if Stan thinks it's pretty good, Minson's likely to think it's good. And quickly scanning, you can see that these numbers are quite similar. So pause the video and have a think about whether the Pearson's product moment correlation coefficient is going to be closer to -1 or 1. Great, hopefully you realise it was going to be closer to 1. So what we're going to do, like a lot of these topics, we're going to go onto the Start menu and we are going to first of all click Edit. We can see we've got lots going on in the Start menu today, so we need to make sure we clear all of the lists. The way we do this is we press Stat and number 4, and what I did wrong last time is I didn't specify the lists I want to clear. So we need to look for clear list 1, list 2 and list 3. The way we do this is press second 1 and that will bring up list 1 in the blue. Then we need to do a comma, second list 2, comma, second list 3. And I'm doing this because for my data I had 3 lists with data in. And then remember, obviously you need to press enter and it says done. If we go back onto the Start menu, back onto the Edit menu, you can see everything is completely blank. However, for this set of data, we need to make sure we're just entering data into 2 lists. What you've got to make sure is that you don't clear off the page too quickly and that the data is inputted properly. We need to press number 4, which is linear regression. List 1, list 2, leave this blank, calculate. Fairly straightforward. Okay. So this looks really good. We have got our straight line function, but we haven't got R. So the calculator often does this. So you need to change something in the calculator. We need to go onto Stats Diagnostics, and sometimes this for some reason is turned off. So make sure it is on. Go back to Start menu, go back to Calc, go back to number 4. Excellent. We have R, Pearson's product moment correlation coefficient. This is 2 marks and it's really quite an easy 2 marks in the exam. I would say this demonstrates that the relationship between Stan's score and Minson's score is a strong positive relationship. So we're happy with 7a, 7b. Write down the equation of the regression line y on x. That's really easy. You just use this screen and you substitute in the relevant values. Easy peasy 3 marks. If you've got question 7a, 7c is really straightforward. Use your regression equation for part B to estimate Minson's score when Stan awards a perfect 10. So for this one, I'm going to show you Desmos. So pause the video and have a think about what this B means, or what does the C mean in the y equals mx plus c. Welcome back. Hopefully you realise this is where it crosses the axes, the y-axis specifically. So if we want to predict things, let's just talk about how this graph works, because you won't need to know this, but this really helps for the contextual descriptive questions. We're going to say that we've got along one of the axes, we'll have stand score, and this is the x-axis. This is because we wrote down the x variable first, and along the other axes we've got Minson score. So this is going to be Stan's, this is going to be Minson's. So let's say Stan gave a score of 8. So for Stan's score of 8, we're going to get that Minson scores 9.701. For Stan's score of 5, we're going to get Minson scores of 6.28. And so if we had 10, you'd click a 10, and then you'd find what Minson's score is. So, double checking, we've got Stan on the X and Minson on the Y, that's absolutely fine. But you won't have Desmos, so what you'll have to do is just simple substitution. So, we're going to take the equation. If we want to work out what Minson's score is, Minson is the Y. So let's label the Y with Minson, and Stan is going to be the X. So all you would have to do in this is you'd have to just substitute a 10 into this equation. That's all you would have to do. Now, as I said before, what we need to do is substitute the 10 in. They've just used the unrounded format and they get 11.98. So happy days with all those questions. State whether this estimate is reliable. So you've got to go back to the question and have a think of what this suggests. It says the competition is out of 10. So what is the problem for part D? I'll just remind you of what the answer was for part D. 12. Well, clearly that is more than 10. So we're going to have to say something like that. No, the estimate is not reliable. So you get 1 mark for saying yes or no, and you get your second mark for saying outside the known data range, or score greater than 10 is not possible. So the first thing they've done is they filled out B to be 8 and G to be 1. Can you pause the video and think about the significance of B being 8 and G being 1? Welcome back. Hopefully you realised that this was to do with, or this is to do with, ranking different scores. So Spearman's rank is to do with giving a rank to different things. So we are going to rank things from best to worst. The idea of this is to simplify the data we're going to analyse. So rather than having a whole variety, a whole spectrum of numbers like we have in the actual question, we're going to simplify the numbers so that the relationship is going to have less variation. And I will show you what I mean by that. We're going to look for the best score in the x-axis, or for Stan's score. Stan's overall best score was 7.5, so we're going to number that 1. Stan's next best score is going to be 7.1, so we number that number 2. Then we're going to think about where we go next. So I'm going to start thinking about his worst score. So his worst score is 3. His next worst score is going to be 4.1, so this is going to be number 7. And then we're going to have 4.3, which is 6. And now you might wonder, well, why have we labelled H as 4? And there's a real specific reason. Now there's 3 left. 6, 6, and 6. And out of our number ratings, we've got 1, 2, 4, 6, 7, 8. Let's ignore the H for now and think what's left over between 2 to 6. Well, the jumps between 2 to 6 are 3, 4 and 5. And because 6 represents a score equal to 3 rounds or 3 contestants in this competition, we need to pick a number which is in the middle of the numbers left over, because we're going to repeat this number 3 times. So we're going to have 4, 4, 4. So it's a bit like saying this was the first winner in his eyes, second winner, then these were joint 4th, 6th, 7th, 8th. In a typical competition, you might say these are joint 3rd. However, that doesn't take into consideration the equilibrium and the balance we need to create between 3, 4 and 5. Now we're going to repeat the process for the Minson's rank. So we've already done player number 1 or contestant number 1. This is going to be contestant number 2 because this is the next number closer to the 9.5. Now we're looking for numbers in the 7s. 7.8 is the next one. 7.2. Well, luckily it's already decided what the rank of 7.2 is, so we don't really need to even calculate it. So let's just put that as 4.5. This would be using similar reasoning as before. We're going to say it's halfway in between 4 and 5. And then we're going to have, let's go back from the smallest numbers. So 4.6, lowest score is going to be 8. Then we're going to have 4.7, that's going to be the second lowest score. And then the third lowest score is going to be the 6th one. There we go. And Spearman's rank basically means we're doing the same as Pearson's, but we're going to apply these numbers to our table rather than applying the original numbers. And it just oversimplifies the model, so it's easier to discuss, for example. So we're going to go to Edit, and we're going to type these in now. So before we do that, we're going to clear them as we did before. Clear list 1 and list 2. Then we're going to go into Stat, Edit. These are going to be much easier to type in because they're not decimal numbers, other than the couple of exceptions. So now we're going to apply the linear regression as before. So we go to the Stat menu, Calc menu, linear regression, list 1, list 2, the rest needs to be blank, and calculate. And what we can say then is for 1F, we just did that on the PowerPoint slide. 1G, we've got 0.9326. And we finally, for 2 marks, need to comment on the result obtained for RS. So let's have a look at the kind of comment you would state. So for the final part of this question, we would just repeat the fact they strongly agree on the ranking. So rather than talk about the correlation, you just change the word correlation to ranking. You get 1 mark for strongly agree and 1 mark for ranking, and that's clear. We're talking about ranking, so make sure you include ranking. And there's one final question now. The Commissioner believes Minson's score to competitor G is too high and so decreases the score from 9.5 to 9.1. Explain why the value of the Spearman's rank correlation coefficient does not change. So let's have a look. So we're going to go to Minson. He is the Y category. We're going to change 9.5 in the original table to 9.1. This is quite a difficult thing to explain. And the reason why is because you probably understand what's going on, but to verbalise it, you might struggle. So we can see that 9.1 is still the highest rank, even if you change 9.5 to 9.1. So that's all you really need to say in the exam. You don't need to overcomplicate it, but I can imagine that you might confuse the wording of this. So let's have a look at the specific wording to get you the full marks. Decreasing the score to 9.1 does not change the rank. So you need just to talk about what is the action, or the actions described in the question, and then just explain it doesn't change the rank. If Spearman's rank did change, then you would write it does change the rank. So actually there's a standard response here you can memorise. I hope you found that video useful, and let me know if you've got any questions.